Good morning. I'm all logged in now and everything should you should be able to see the desktop and hear me. Does that seem okay now? Let me get the windows popped up. Let's see. Okay. Okay. Do you hear me? Does everything seem okay? Do you see the desktop and you hear me? Yes. Okay. Thank you. Okay. All right. So first thing, just wanted to quickly remind you that the university has a final exam schedule that the all the courses are supposed to use. So here it is, and you look up a final exam by seeing what day of the week your classes start. So first day of the week, our class is on like a Tuesday morning at 9:30. So you get down here to Tuesday. Okay, Tuesday between 9 and 9:59. Our exam is see on Thursday. Okay, Thursday morning. Okay, so the exam will be on Thursday, but it's going to be just like the other two exams. So I just want that's 2 weeks from this coming. That be the final exam week is the first week of May, so that would be the 6th. Okay, so I just want to show you that just let you know that that's coming up. Uh, like I say here, the exam will be just you'll download the exam from Brightspace just like the other exams were. So it'll be Thursday, May 6th. We don't meet that week. Just to let you know, during final exam week, there are no classes. So then this week here, there's only going to be exams. Classes don't meet. And I'll put up review problems in a few days. So let you know, like there were review problems. Actually, the the review problems will mostly be what you've seen already, plus what we've talked about since the second exam. So the review problems will be for the new stuff, and then there's the review problems and your exams to look at for the rest of the stuff. So we'll talk more about that when I get the review problems up there. We'll talk more about that. But I just wanted to remind you that that's coming up real soon. Okay, and then there's another reading assignment, a little bit more about classes. That's what we're going to continue talking about today. And then the other thing was there's a homework assignment out there. So this is the current program assignment. Does anybody have any questions about this homework assignment? If you had time, it's due a week from to due a week from today. Does anybody have any questions about it? Anything that you have the time to look at it for a while now. Does anybody have any questions they want to ask about the homework assignment? Anything at all? Anybody? Okay. If you have questions, please send me an email or come to office hours. I got office hours this afternoon. Send me an email or come to office hours. But the assignment there's it's not a trivial assignment. Don't wait till the last minute. But it's a good assignment it's good practice on what we've been doing in Java. Okay. All right. So what I'll do today is continue what we're doing. Continue actually with this example here. We were talking about designing a rectangle class. Okay, so we want to keep doing this example here. We'll keep talking about designing a rectangle class. The idea is that we're designing our own class here, and that's what the current chapters of the book are about: are designing your own class. Now, what we're doing, classes represent something. Yeah. So in our case, classes represent an idea of a rectangle. And a rectangle class would be used in it could be used in a geometry program, but more practically, a rectangle class is used for drawing GUIs and drawing graphics. If you notice, everything is a rectangle in front of you. When you look at a computer screen, computer screens are based on rectangles. So even simple things like you pop up a menu, it's a rectangle. You highlight something and there's a small rectangle. So almost everything is actually designed in rectangles. So there's a lot of use for rectangles in computer graphics. And Java even has its own rectangle class. So you can look it up. we're writing our own rectangle class, but here's a Java. This is the Java description of a rectangle class. Notice it has two, like ours, it's got 4 things in it. We said our rectangle would be an X and a Y coordinate and a width and a height. And if you look at Java's, they did it exactly the same way, an X and a Y coordinate and a width and a height. It's the upper left-hand corner. I think which corner did we use? We used lower left-hand corner. See, now everyone agrees on that. We used the lower left-hand corner. So in our picture, we used the lower left-hand corner and the width and the height. They actually use the upper left-hand corner. So in their way of thinking, they picked this point here, up here is the point of the rectangle, and then the width and the height. Okay. So not every, different. Once you pick a way, when you design something, you pick a way of doing the design, and then you work from that design. You work from the choices you made. Okay, like Java also has a something called rectangle 2D. They actually have several different rectangle classes. Okay, notice that this one's a little bit more complicated, how they designed it. See, it's a little bit harder to read what's going on in this one. Okay, and then they even have another rectangle class here. Okay, so they have several different rectangle classes. So we want to play around with just designing what we think is the right thing to have in a rectangle. If we're going to design a class where the objects represent rectangles, and the key idea is represent. These classes aren't real rectangles. A rectangle is something you draw on a plane. They represent them. Okay, and later on, we'll do examples like we'll have a class that represents an employee of a company, or a class that represents an order, an online order. You design classes that represent the things that programs have to be about. So it's you can have a class that represents a shopping cart, and the shopping cart class would hold orders, and you can design a class that is an order, and it would hold a item and its quantity, and then you'd have to have a class that represents items that you sell. So you keep modeling the things that when you're writing a program, you keep writing classes that model the things the program is about. Okay, so right now we're going to stick to the rectangle class, and then we'll think of a couple other things that we could add to it to make it more realistic. Okay, now so far our rectangle class holds data that represents a rectangle. We represent a rectangle by 2 numbers that are the upper left-hand corner, what do we say? The lower left-hand corner of the rectangle. And we also then have 2 more numbers that are how wide the rectangle is and how high the rectangle is. Okay. And then we have this thing that looks like a method, but has the same name as the class. That's a constructor. That's what you use the word new with to get a new rectangle. So like here, I would have newed 2 rectangles. Okay, and the constructor takes values for these fields. These are called the fields of the object. This is called the constructor. Okay, the constructor takes values for the fields. So you have to copy these values into the fields. So you copy them one at a time. You take that value that's from the constructor and put it in that variable, which represents the object. Okay, and this is actually one of the tricky ideas. This is a variable and this is a variable. That's a variable. That's a variable. What are they doing that's different? Okay, this variable, if you think in terms of the Java, let's visualize it. This is one of the subtle things they get used to. Like, here's a call to the rectangle constructor. There's 4 numbers, 0, 0, 4, 5. Okay. When I step forward, I'll step into the constructor. Okay. So I step forward and I'm now inside the constructor. Here's the object that I'm building. Okay. Now, these variables aren't part of a method. They're part of an object. So we've got kind of a new idea. So far, all the variables we've looked at were variables that belong to a method. That's what, see, this variable here belongs to a method. So it's over here in the left-hand side of the picture. Okay. You've called the constructor method. They give it a kind of a funny name. Init stands for initialization. We are initializing an object. Yeah, they probably should have put the name of the object there. Should have said rectangle there, because we're calling the method, we're calling the constructor called rectangle. But for some reason, the designers of the visualizer decided to put the word init up there. We're in the initialization of this object over here. Notice that we have this variable. No, there's no variable over here called this. This variable is automatically there as part of the way Java works. And it represents an arrow to this object that we're building. We're calling a constructor to build an object. Which object are we building? This one. Okay, we're building this object. The fields are in the object. So when you read this code, you think of these as sitting in objects, but you think of these as part of a method. See, so they play very different roles. When you see these variables that are just they're usually declared right at the beginning of the class file. They don't have to be. You can put them at the bottom of the class file. Some people do. Some people put these at the end of the class file. The order doesn't matter. Usually, but it's easier to read if they're at the beginning of the class file. These variables are the fields of the object. The object holds that data. Okay. The constructor is given values to copy into the fields of the object it's building. So now this constructor will put those values over in these values been copied over there into the object. So now this object has been initialized. It's been constructed and initialized. Okay, so now we return. Now the constructor doesn't return anything. See, there's no word over here for return. It doesn't return anything. It built this object. It doesn't actually return the object. It built the object. Okay, but it actually does return a pointer to the object, and it's really kind of quirky that it shows it returning nothing when it really is returning an arrow to that object. Just like our methods that could return object. We wrote methods that returned arrays last week, and the method would return an arrow to an array. So this is actually really returning an arrow, even though it says here that it returns void. They should have, people who wrote the visualizer should have realized that it returns that arrow to there. So it's another little quirk of the visualizer. They're correct to say void here, because there is no return value here. Java technically doesn't have return values for constructors, but it does. They're just implied return values. It returns an arrow to the object that it built. Okay, right? So now we've returned to that variable the arrow to the object that we just built. So now we have an arrow to that object. Now here we're going to build another object, and we're going to have another variable. Notice that this is a variable in main. See, it lives over on this side of the picture. X, Y, and width and height are variables inside of an object. They're fields. They live on this side of the picture where the objects are. If we construct another rectangle object, see, we got now an X here and an X here, a Y here and a Y here, width here, width here. This width is inside the new rectangle that's being built. This width is inside the rectangle that was built a little while ago. So there's a width inside of this rectangle and a width inside of this rectangle. So you got to be careful about these variables here. This variable is not in your program one time. This variable is in your program as many times as you created a rectangle object. This variable is only in your computer one time. There's only ever one of these variables. When you call this method, you get one variable called new x. Then when the method returns, that variable goes away. These variables don't go away. They're inside the object. Okay, and unless the object goes away because it gets garbage collected, the variables don't go away as long as there's the object over here in the object side of the picture. Okay, so these variables are really different. These are called parameter variables, and these are called instance variables or fields. Okay, So they're called fields or instance variables as opposed to parameter variables. Okay. And they just, you imagine these objects as floating around in Java, and each object holds a copy of each one of these instance variables. Okay. Now, this constructor initializes this other object. So notice that there's completely different numbers in here than there are over here. Okay. And then it returns a reference to that object. So now we got two objects. Okay. Right. Now we're going to let's go back to the code and think about it. Now, besides having the constructor that builds objects, we have methods that can make the object do things. Okay. And like when you have strings, you have objects that do things like tell a string to uppercase itself, or tell a string to give you back a substring of itself. So we have methods you can call on strings. We had methods you could call on turtles. We could tell a turtle to move forward, tell a turtle to turn right, tell a turtle to turn left. So here we're going to have rectangles, and we tell them to move. Okay. Right now we have a couple methods. We can tell a rectangle to move. Move by was like, if this was 2, you'd say move by 2 units. This was another kind of move 2. If this was 2, that would put the upper left-hand corner at x equals 2. Okay. So this one moved to this point xy. This one moved by the change in x. This is actually a change in x and a change in y. In fact, probably a better way to call this is delta x, because that's the word that almost all programmers use when they say something changes. It comes from calculus. You have delta x and delta y. The derivative is delta y over delta x. So programmers use that terminology a lot, delta, to represent a change in. So then x changes by delta x. Now that's better than what I had before, because before I had just an x here, but that x played a really different role than that x. So like I realized now I could give this x a better name to help somebody read it, that's the x you change by. In a move command, you change by delta x. Okay. So then you add delta x to x, and you add delta y to y. Okay, so that makes the code so now that's one of the things about writing code is when you think of a better way to do something, it's a good idea to make an improvement. Okay, so you don't always think of everything when you're writing the code. Sometimes you'll think of something later on, and it's a good idea to go ahead and make improvements when you think about them. Okay, so you move by a delta, but you move to that x, that y. So this is a point to move to, and this is an amount to change by. Okay, so now notice that this changes the x in the object. See, it says this x. Okay, notice that the x variable is not part of this method. The x variable is part of this object. Okay. Now, if I wanted to, I don't have to use the word this there. There's only, now see, now I changed the name from x here to delta x. That means that there's only one x in this. There's no x in this method anymore. Since there's no x in this method anymore and no y in this method anymore, the only x in my program is that one there. Okay? And the only y in my program is that one there. So I don't need to say this x and this y. So I'm saying take x, which is him, add delta x to it. Delta x is this here. And then take the new result and put it back in x. Okay. Similarly for y, take y, which means read this value, take this variable, which means read what's in here, add them together, and store the result back in here. Now notice when I say move to x and y, well, that x conflicts with that x. See, there's two x's in my program now. What I want to do is copy x into here. This is actually giving me the new value for the corner of the rectangle. And the way I write that is I say, well, the x, which is this one, gets copied into this x, which is the x up here. The notation is very quirky, and this is something that really has to be gotten used to. If I wrote this here, notice I'm using the word this, and the word this is terrible because if I write this here, okay, if I delete this, now my code doesn't. It actually makes sense. Java will compile it, but what I'm doing is I'm copying X into X, and I'm copying Y into Y. So these lines don't do anything. Java won't warn me that there's a mistake here, but all I'm doing is I'm copying this value into itself, and I'm copying this value into itself, which doesn't do anything. I wanted to copy this value up into the field, which is part of the rectangle. The field would be this X, and the other field is this Y. So here's an example where I don't need this because there is no X and Y variable here. And this example, I do need this because my parameters here are called X and Y. Some people don't like to do this. Some people do something like the following. They'll say new X and new Y. Okay, then I can say, then I don't need this down here. Then I can say the X that's in the field is the new X. And the Y in the object gets the value, the new Y. Okay. Most Java programmers don't do it this way. They don't come up with new names for these things. They just if this is a value that belongs there, they call it by that name and then use the notation we had just a second ago. Yeah. Call this X and call this Y, and then just say, move that X up to there. Now, actually, to remind you that there's so many different ways of doing this, let's kind of write it three ways. Only one of them we can use. Okay, so one way to write this is new X, new Y, and then I don't need the this. I make this new X and new Y. I could write it that way, or I could write it this other way, where I use X and Y, and I say this X equals X and this Y equals Y. Okay, so there's more than one way to do it, and I'll comment out one of them. But leave them both in there, so because the idea is that when you write the code, you actually get to choose which way you want to do it. If you like the idea of giving this guy a different name so that you can just say X equals new X, actually, and even here you could still write this. It doesn't do any harm to write this in front of that X. Okay, if you go down here and you put this in the wrong place, this gives you a really tricky bug in your program. If you do this, you do a really strange thing. It'll compile and run fine. And what it'll do is it'll take the value in here, which is this X, and copy it into here, which is kind of pointless because this variable is about to disappear. As soon as this function returns, this variable goes away. But it's going to take what's up here and copy it into here. Okay, so where this is matters a lot. So this would be a real subtle mistake to make. Okay, so the destination for this value here is this variable up here in this object. So this X belongs in this X, which is part of this object. And you can see that the word this is just a real mess to be using here. Unfortunately, you use the word this so much in English language that calling that variable this variable was not a good idea. Because as you talk about programming, you're going to be using the word this constantly, but sometimes the word this means that this variable in Java, and sometimes the word this is just a this in the English language. Okay, so I want this X value copied into this X value, so I use this to mean this object. I use this to mean this object. which is this X up here, as opposed to this X down here. And you know, the word this is it's just all over the place now. Okay. And that takes real getting used to. The word this is just going to be, it's just going to be everywhere now. Okay. So a lot of textbooks teach it this way to make things easier. Then they can actually avoid the word this. Some textbooks teach it this way, but you won't, but programmers tend to write it this way. So you got to get used to using this. Programmers do use this all the time. A lot of textbooks avoid this by giving all the variables different names. So up here in the constructor, I did that trick up here in the constructor. I started off by giving all these variables different names. I didn't use I didn't call this one X and this one Y, and then use the thises down here. Okay, so I used one style here, and I'm using the different style here. If you wanted to, here's how the constructor would look in the other style, which is a good thing to write. Okay, in the other style that actually is used by more people, this would just be X. This would be Y. That's the new Y, the new X. This is width. And height. Okay, and then down here I'd have to say this X, which is the object, gets X. That's the parameter. And this Y is going to be the parameter Y. So I'm going to copy this Y into this Y. Okay, and then I have to say this width is the width, and then this height is. Okay, so there's two ways to write this. I'll comment out this one because I can't have two ways of doing it. But you can see that it's really kind of a choice. Majority of real programmers use this style here with the this in it. But a lot of textbooks teach it like this. But almost all programmers choose to write it this way. So here I'm using kind of this might, you might find this easier to read. This variable gets copied into that variable, and this variable gets copied into that variable. Okay, but the same thing here. I want this variable to be copied into that variable, but then I have to use this in front of that variable. Okay, all right. So here's two ways to write the same constructor, two ways to write the same method. This method doesn't have any conflict because if I give this variable a good name, this is a change in X. It's not an X, it's a change in X. So that's a good thing for me to do, is to think about it and give it that name, change in X. Okay. Now, if I do write this one the other way, remember, it's just kind of good to think about all the different ways. If I give this one kind of not the good name, now it's moved by X, so that means you add X to X and you add Y to Y, but now you gotta be real careful. Now it's this X is this X plus X, and it's this Y equals the previous Y, plus the parameter Y. Okay, so there's two ways of writing that method. I'll only keep one. And when you go back and go through these and think, what's the difference between those two ways? And which one's better? Well, in reality, this is the better one. Okay. Why these two ways? Which is the better one? This is the better one here, the one that doesn't use this. Notice that this was the better one that did use this. This is the better one that doesn't use this because it's got better name for the parameters here. They're deltas, they're changes in X. So that's a better name than X. So this one turns out to be better than this one now. Okay. What about over here? Which one's better here? Well, these are X's. Actually, here it's about 6 of one, half dozen of the others. You'll really find a lot of professional programmers who would just say a new X and a new Y, and X gets new X, Y gets new Y. Okay, I mean, this is really 6 of one, half dozen of the other. I think the majority of programs, a slight majority, would use that because it's like the constructor. It's using the same style as the better version of the constructor. Almost everybody writes their constructors that way. And so then I should kind of write, if I write this in the style of the better style of the constructor, that's more common. Okay. Okay. So you don't write redundant code when you do coding in the real world, but it's a good idea to put these comments in here to remind you that it could be this way, it could be this way. Your goal is to get used to both ways because you'll see both in the real world, and to understand, why do I claim there's two ways of doing it? The key idea is that there's something coming in that needs to be moved up to here. Okay, these are called X, Y, width, and height. You don't have any choice about that. You do get to choose what you call the data coming in. If you give it the same name as what's up there, you have to use the this parameter. You have to use the this variable. If you don't give these guys the same name as what's up there, then you don't need to use this. Okay, all right. So just choices and thinking about what makes one choice better than another. Okay, all right. So these methods they change the rectangle by changing what's inside of the rectangle. They change the data that's in a rectangle. Okay, so if we go back and now and visualize those couple methods, after we've stepped through building the objects, okay, there's the two objects. Now we're ready to move them. Okay, now we're going to tell R1. Well, R1 is not an object. I may say this, but R1 is the name of an object. Don't count variables because, just to remind you, okay, here's a third rectangle. No, it's not going to be a third rectangle. It's going to be a name for the other rectangle. Okay, don't count these and say they're rectangles. These are names for rectangles. There are the rectangles. There's a new one there and there's a new one there. R3 is a rectangle name, and it's just another name for R2. Then we go over here. There's my two rectangles. Okay, has names R1, R2, and then I give this rectangle another name. Okay, don't count these. They're not rectangles. They're rectangle names. Actually, the technical word we've used is they're rectangle references. They're arrows to rectangles. I got 3 rectangle references, but only 2 rectangle objects. Okay, and now I'm going to start changing what's inside the rectangles. Okay, so I'll tell R1 to move. Okay, now that's a method. So I'm going to, we say we're calling the method on that object. That's the object that needs to move. This object is going to get moved because we're calling the method on the R1 reference. So we're calling the method, well, R1 points to that object. So we're calling the method on that object. So now we're going to jump to that method, but it's that method with this as its reference. It's going to be that method pointing at this object. Whereas if I did our to.moveBy, see, like here, when I call move to, I'll be calling the move to method, but pointing at this object. Okay, so I'm going to call moveBy with an arrow to this guy, and then I'll call move to with an arrow to this other object. Okay, now we're in moveBy with an arrow to what was, where it's the same thing as R1. See, that arrow points to the same object that R1 pointed to because we called the method on R1. We called the method on R1. So this, notice that this replaces this here. When you call the method here, you're saying that this becomes this. You see, it's hard. The thing on the left side of the dot is replaced by this. So R1, I'm calling the method on R1. So R1 is replaced by this inside the method. So I'm inside the method now, and R1 is replaced by, so I got an arrow to this. See, I'm pointing at that object. Now I want to update X by the amount 3. So I want to move X by 3. So I moved X by 3. And I want to move Y by 2. Okay, right? So I moved Y by 2. Now I'm about to return. I don't return anything because my work was all done inside this object. I don't return an answer from this method. See, this method returns nothing because it did its work by changing that object. So the work of this method is not to return an answer to me. The work of this method is to change the object. In a minute, we'll see a method whose job is to give back an answer. Okay. Now I'm going to move this other object, the one that's called R2. Notice I'll also be moving R3 at the same time. R2 and R3 are names for the same rectangle. If I move R2 and I then looked at what's inside R3, I'll see the moved R2. I'll see the moved rectangle. Okay, so now I've got this pointing to this one, which is the same thing as R2 and R3. Okay, so I'm up here. This points to the object I'm working on. Okay, and now I'm going to update the X and Y coordinate again, but this time I'm going to move to 5, 10. Okay, not, instead of moving by an amount, I'm going to move to that value. So I'm going to move to 5, 10, right? And now I return. Okay, now notice that R2 was updated, and so is R3. Okay, now here's another method, area. Area says how much area does that rectangle have? Now it gives an answer. There's an example of a method. Here's a method with a return value. Area should tell you back a number. The number it gives you back is whatever the area of the rectangle is. See, that's different than move. Move doesn't give you back an answer. It changes the object. Move to doesn't give you back an answer. It changes what's in the object. And methods, some methods change the object. Some methods give you information about the object. Okay. They're generally called setters and getters. That's kind of I don't like that terminology, but this is setting something in the method. This is changing the object. It's setting the object to have different values inside of it. This is getting something about the object. It's getting information from the object. It's getting the area of the object. Okay. So roughly, we have two kinds of methods. Methods that update the object, which people generically call setters. They set what's in the object. And getters, which get information about the object. The setters always have they have void. The more fancy term for setters are mutators. They mutate the object, make a change in the object. So the more general term programmers use is that these are mutating methods. They update, they change what's inside the object. They go into the object. See, they go into the fields in the object and update those fields somehow. They go inside and change these numbers. Those are mutators, sometimes called setter methods. Okay, area is a good example of a method that doesn't change anything in the object. It gives you back an answer about the object. And all in all methods either make a change to the object or report information about the object. That's what methods do. They either change and you guys remember, that's the whole goal of methods. You have an object and you write two kinds of methods in the object. Methods that update the object and methods that give you back information about the object. Okay. In our case, we only have a few methods. Move by updates what's in the method, and area gives us back information about the method. Now, in a minute, we'll look at the overlapping. It would be one that gives me back information. Overlapping tells me information. Does this rectangle and that rectangle overlap? that's information about the rectangles. It doesn't change anything in the rectangles. So overlapping would be like area. It's a getter method in the sense. It's getting information about the object. In this case, does it overlap with some other object? Okay. All right. Now, in the case of, now remember, we're calling area on that object, and we're going to return width times height. So we take the width and the height, and we're going to return 1. See, just the width times this area, the area of this rectangle is 1. Okay. So that got returned to the new variable a. Okay. Okay. Now let's do the, now we worked on last week this more complicated method, the overlap method. This is actually, notice there's a fair amount of code here. It's a more complicated method. If you go back over here, when do two rectangles overlap? Yeah. Some corner of one of them is inside the other. See, these overlap because this corner is inside the blue rectangle, and this corner of the blue rectangle is inside the black rectangle. The only way two rectangles can overlap is a corner of one of them is inside the other. And if I go over here and if I draw a bunch of rectangles, you can see there's a bunch of different situations. It's actually a little bit tricky to do. Okay, so here's a rectangle and another one that don't overlap. Okay, no corner of this rectangle is inside that one. Okay, here's another rectangle. Here's no, and now notice those overlap. No corner of this rectangle is in that one, but all 4 corners of this rectangle are in that one. Okay, so that's overlapping. In this case, all of these corners are inside that one, but notice that none of these corners are inside that one. Okay, on your hand, I could have something like this. They overlap. 2 of these corners are inside the bigger one. None of the bigger corners are inside the littler one. Again, so and oh, here's another, okay, now here's another situation. Here's a rectangle, and trying to think of okay, well, here's the simplest case. One corner of this rectangle is in this one, and one corner of this rectangle is in that one. That's kind of like your normal case, but that's only one of the. So this is non-overlapping. This is one way they can overlap. This is another way they can overlap. This is another way they can overlap. Let's see. Can I come up with another one? This one has all 4 corners of one rectangle in the other. This has 2 corners inside the other one. This has 1 corner of each rectangle in the other one. Let's see, is there another way they can overlap? Non-overlap means no corner of one is in the other. You can have all 4 corners of one inside the other because it's one rectangle is actually sitting inside of the other rectangle. They could overlap. They can overlap in this kind of classic way where one corner of one is in that rectangle, the other corner is in this. So each rectangle has 1 corner of the other in it. And you could have 2 of them. Let's see, there ought to be another way. Is there, anybody think of it? Is there one that, can you have 3 corners of one rectangle in the other? You could have 1 corner, 4 corners, 2 corners. If you think about it, you can't have 3 corners of a rectangle sitting inside of another rectangle. Okay, you can't really do, oh, actually, let's see. You could do something real, well, here's an odd case. Okay, there, that's kind of an odd case. The red rectangle has 1 corner inside the black rectangle, and the black rectangle has 3 corners inside the red rectangle. Okay, okay, there's an oddball case. The black rectangle has 3 corners. Oh, I'm sorry. The black rectangle has all 4 corners inside the red rectangle. So the black one has 4 corners inside the red rectangle, and the red rectangle has only 1 corner inside the black one. Okay. And then I could do another case. Here's a red rectangle, and then I could draw a black one, say, oh, whoops. I wanted to make the larger rectangle red. And then, let's see, I could put a black one like this. Okay, so now 2 corners of the red rectangle are in the black one, and all 4 corners of the black one are in the red one. Okay, so you notice how you can get lots of different cases. And when you write a method like what we were going to do over here, when we want to write a method that says, okay, I want to know if 2 rectangles overlap. I have this rectangle and that rectangle. Okay, and I don't want to think about 1, 2, 3, 4, 5, 6, 7. I don't want to think about all these different cases. So I look for an idea that's kind of like common to all of them. And the idea that's common to all is that rectangles only overlap if at least one corner of one of them is inside the other. Okay, that's all I really need. I need one corner of one of them inside the other. And oh, here's another little example. Here's a rectangle, and then there. I'll say they overlap because the one corner of that rectangle is in the other one, and one corner of that one's in there. So there, see, they just barely touch. Okay, so they just barely touch. One corner of each is in the other. Okay, so I'll say they overlap if one corner of one of them is in the other one. Okay, okay, and yeah, this case means I can't say that each has a corner in the other because the big rectangle here has no corner in this one. Okay, but this one has all 4 of its corners in that one. Okay, so my idea of now this is the hard part of programming. Somebody gives you a problem, figure out a way to figure out if 2 rectangles overlap. Okay, and then you really have to, you draw pictures, you think about it, and you start, and finally you realize, okay, the key thing that I can write my code to check is if a corner of one of them is inside the other. Okay, so I go over here, and these 4 lines ask if one of the 4 corners of that rectangle is inside this rectangle. And then I had to write a method inside that asks, is a point inside of my rectangle? So notice I ended up breaking the problem down into 2 methods. Okay, and this is where real programming comes in. Thinking like what I really wanted was this method, but I realized that to make this method work, I need another method, something that can just say, if you give me a rectangle and you give me a point, can you tell me if the point's inside the rectangle or not? Yeah. That's a separate problem, but I need that problem to do the overlapping problem. So I think, well, if I can solve the problem of given a point and a rectangle, is the point inside or outside the rectangle? If that method would be real useful to write this method. It might actually be real useful for a lot of methods. Knowing inside and outside could be real useful for lots of methods. So I realized that to write this method, it'd be good to have this method. So I write this method. Inside is a point inside of a rectangle. Okay, and a point inside of a rectangle if it's either between the left and the right edge. Well, it has to be both. So you notice this guy is between the top edge and the bottom edge, but he's not between the left edge and the right edge. Another point over here. This is between the left edge and the right edge, but it's not between the bottom and the top edge. Okay, this one's between the top and the bottom edge, but it's not between the left and right edge. You're inside if you're between the left and the right edge, and you're between the top and the bottom edge. Okay, so inside is you're between so your point, the x coordinate of your point is to the right of x. This is the left edge, and this is the right edge. See, the left edge is x. In our case, our x is going to hold our left edge because x is our lower left-hand corner. So x tells us where the left edge is. X plus width tells us where the right edge is. So the x coordinate is to the right of x and to the left of, It's to the right of the left edge and to the left of the right edge. The y coordinate, see, then I say and the y coordinate is above the bottom edge and below the top edge. So this would be above the bottom edge, below the top edge. To the right of the left edge, to the left of the right edge. Okay. Yeah, I have to read it real carefully. Can't avoid math when you're writing programs. Believe me, there's surprising amount of math is everywhere in your writing programs. Okay. And rectangles are going to be part of all graphics programs. They're going to be part of all games. And the only way to work with a rectangle is to work with the numbers in the rectangle and work with inequalities, and logic. Okay. So point inside, the x coordinate is to the right of the left edge and to the left of the right edge. The y coordinate is above the bottom edge and below the top edge. And if we look at the picture, we see that's pretty good. Yeah, I'm sorry, the other picture. Notice you need both conditions. This guy, he's above the bottom edge and below the top edge, but he's not between the left and right edges. This guy's between the left and right edges, but he's not above the bottom edge or below the top edge. Okay. And the one that's inside is between the left and right edges and between the top and bottom edges. Okay. Now, once I have inside, then I can go back to overlapping. Okay. Here are the four corners of a rectangle. X and Y are the lower left-hand corner. X and Y plus height is the upper left-hand corner. Remember, so think XY is the low. Pick this rectangle here, for example. Start down here at the lower left-hand corner. That's XY. Okay. Then X and Y plus height is that point up there. That's this one here. X and Y plus height. X and Y plus height. There's X. Y plus height puts you up there. Then the next one's going to be over here. That would be X plus width. You take Y, you'd start here, add height, add width, and you're over in this right-hand corner. That's this one. See, I'm going around this rectangle clockwise. I'm starting at the lower left-hand corner, and I'm enumerating the points on the rectangle clockwise. This is XY. This one's X and Y plus height. Then over here is X plus width and Y plus height. That's the third one. Okay, then this one down here would be, you just move to the right. So it's just, Y stays the same and you move X to the right. So I'm enumerating the four corners and checking of that rectangle and checking that each one of them is inside this rectangle. So I ask, so if I take one of these examples here, is if this bigger one is that and the smaller one is this, okay, I'm asking, is this corner inside that rectangle? No. 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 Then I switch around. Then I switch and ask, are the four corners of this rectangle inside of that rectangle? So then I would switch and say, is this corner of this rectangle inside that rectangle? The answer is yes. Is this corner inside that one? The answer is yes. When you go around, and you'll get 4 yeses. So you had 4 no. So notice that you can get 4 no's and then 4 yeses. This one would give you 4 no's and 4 no's. These don't overlap. So you'd get no, 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 no. Or in our case, you get false, 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 false. Okay. Example like this would give you, out of these 8, it would give you false, 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 true, true, false, false, false. It'd give you 2 trues and 6 falses. But it would give you true, see, these are ORed because they overlap. If one of these is true, then one corner of one rectangle is inside the other. So we need any one of these to be true. So this is all being ORed together. I've got 8 things that I'm ORing together. It's a real good example of kind of a medium-sized tricky thing to write in Java. And it's a real interesting geometry problem. How do you determine if 2 rectangles overlap? Okay. And given that I'm describing a rectangle by its corners, I'll tell if they overlap by checking their corners. So check the 4 corners and then use this extra method to tell if the corners are inside or not. So check if all 4 corners of that rectangle are inside this rectangle, then check if all 4 corners of this rectangle are inside that rectangle. Okay. All right. So that gives me a notion of inside and outside. And you can see that we're using almost everything we learned about here. We're writing a method that takes a parameter that returns us, in this case, a Boolean. It's written using logic. Okay, I have to use ORs in this case. So it's this or, so the answer is this answer or that answer or that answer. So I want to know if one of these is true. I'm calling other methods inside of this method. So this method does its work by calling the inside method here over and over again with different parameters. I'm using objects because I've got 2 rectangles I'm working on. There's this rectangle and that rectangle. So let's watch it work on one. Okay, let me step up to the part where I get to that code. Build the 2 rectangles. Okay, there's the 2 rectangles. Now there's the move. There's the move of the other one. There's computing the area. Okay, now we want to check the overlap. Okay, so yeah, now if you drew a picture, you could tell these don't overlap. Yeah, right now these don't overlap. Okay, so you go over here, and now you're going to check. Essentially, the code's going to check that condition. Well, see that. Well, to check this condition, I have to call inside. So I'm down here on inside. It's going to return false. Now I'm doing this inside. It's going to return false. Now notice the picture is getting complicated. I'm down here I'm inside, which was called by overlapping, which was called by main. Line 84 of main, I can go down here, check, see, line 84 is where I called overlapping. I'm at line 59 in overlapping. I'm at the second check. I'm checking the second corner of that rectangle, okay? And I'm at line 70 of inside. I'm checking the corners here, okay? Okay. Now I'm ready to do the third corner of, now here, see, there's this and that rectangle. I'm checking right now that the corners of that are inside this. Okay, so right now I'm in the part of code up here where I'm checking, are one of these 4 corners inside this rectangle. So I'm checking where the corners of that rectangle are inside this rectangle. Okay, this is the one I called the method on. That is the one that was the parameter. Okay, yeah. So a lot of things going on here. Okay, and these are all going to be false. The return value is going to be false over and over again. None of the corners of either rectangle are inside of the other. Okay, this is checking the last one. Now I'm ready to return false. So I checked all these corners, and now I'm actually back at line 58 to return the false. I checked. Notice that what the stepping thing did is it stepped to this, this. Okay, it did all 8 of these, and then it went back to line 58 to do the return. Now I'm at line 58. Now I'm doing the return. I was at line 58 before doing that method call. Then I did line 59 with that method call, then line 60 with that method call. After doing line 83 with that method call, I go back to line 58 to do the return. Okay, so now I'm doing the return of false. Okay, and B1 says false. Okay, right. And then it doesn't matter if I ask if R1 overlaps R2, if I ask R2 overlaps R1, I should get the same answer. Okay, so the way this is written, if two rectangles overlap, they overlap, and it doesn't matter if you ask. Now these are different method calls, but you'll get the same answer. It does R2 overlap R1 is the same thing as asking is does R1 overlap R2. Okay. Now let's add another thing to our method. I'm sorry, let's add another thing to our class. Here's a quirky thing about this class. Let me write a new constructor. I'm going to write something that should be wrong. I'll put a rectangle at the corner 1, 2, and I'm going to make its width -5 and make its height -3, which shouldn't be allowed. I don't think it should make sense. Should you even have such a thing as a negative width? Okay. Now, in our case, sure. Okay. Okay. Notice that we can build a rectangle. Oh, I have to do a lot of, let me go back and put that at the beginning. I don't want to step through. So let me go and put that at the beginning so we can see it right away. Doesn't make sense. I don't think a rectangle should have negative width and negative height. So let's stop somebody from doing that. Okay, let's go back here and let's make this thing check that there's something wrong here. So what we're going to do is in this is called validating your data. A constructor should make sure that the data in an object makes sense. So we'll say if new W is less than 0, we've got a problem then. Okay. Now we'll say what and then we have another thing to check. If new height is less than 0, we also have a problem. Okay. Now the question is, what should we do if we detect this problem? Okay. There's a variety of things you could do. This is not in the textbook, but it's not a hard thing to do. You do something called, you throw an exception. Throw an exception is a way of saying there's a problem. You throw an exception. Okay. So, and then here, I'll also throw an exception. Now, exceptions are objects. So I use the new keyword. What happens is, okay, now let's watch what happens. So I throw an exception. What that does is essentially halts the program with an error message. Okay. So let me go down here and run it. Oh, let's see. Actually, let me change this to, I think, yeah, change it to error. That's a little bit easier to do. There's throw an error. Okay. Now step through my code. See, my program crashed. It stopped. This is actually a good thing. Programs should stop when they detect that there's an error. Okay. So that way the people using the program could know that something was wrong. Somebody did something wrong. They called a constructor with a number that didn't make sense. Okay, right? So now I've got an idea. This is a new idea now. When an object should protect itself, it should make sure that there's nothing in the object that doesn't belong there. Okay, so like a rectangle shouldn't have negative width and negative height. Now, x and y can be negative. That just means you're in a different quadrant of the plane. So x and y being negative is not a problem, but these two numbers should be positive numbers. And if you don't want rectangles that are slivers, you can make this less than or equal to x. Because a rectangle with height 0 really isn't a rectangle. So you might actually say that you really should make these less than or equal to 0 so that you don't get rectangles that are just a sliver. Okay, now, so now I protect myself. Okay, so now I don't have this problem here. So it's okay. So now here's another problem. What if I do the following? R4 has a method in it, but it also has a field in it. You can ask for the width variable in R4 and set it equal to -5. I've got a problem now. Okay, I protected my rectangle from somebody putting a negative number in it, but then I'm allowing somebody to put a negative number in it. By what I'm doing is I'm saying, just reach inside of the object and put that number in there. See, so instead of calling a method on the object holds a width variable. And if I use the name of the object and the dot notation and width, I can go in there and change the width of the object and put a negative number in there. Okay? And then I could do the same thing with the other. I could change R4 dot height and make it -10. Now, but notice I stopped somebody from putting negative numbers in the constructor, but now I have another problem. They can just bypass my constructor and just poke numbers into my object. My constructor does its due diligence and makes sure that it's not being given negative widths and heights. And then after my constructor has gone through all that effort, somebody just pokes negative numbers in my object. So we need a way to stop this. So Java has another technique you can do. In here, I can mark these variables as private. So I'm going to put a new keyword in there. I'm going to say these variables are private. What that means is that nobody can poke things in them without using a method call. Only methods are allowed now to change these variables. What happens now is this line of code won't compile. Now watch. Whoops, what happened there? Why did that compile? Let's see. Okay, let's see. Now, it won't run. Watch what happens. Wow, there's something wrong. There must be a bug in the visualizer. Let's copy this code into Dr. Java. I don't know if there's a bug in the visualizer in this case. Let's copy this into Dr. Java. Okay, I'm going to go over to Dr. Java. I'm going to start Dr. Java. See, this is a real important, this is one of the most important concepts of all object-oriented programming. You can mark fields as private, and then only methods can put data in those fields. And then Dr. Java started out in the quirky state. So let me quit it and start it over again. Okay, there's my method in Dr. Java, and I need to save it as a rectangle class on my desktop. Okay. I'm doing something wrong because this shouldn't compile. What am I doing wrong? Oh, I think I know what I'm doing wrong. Oh, yeah, you're not supposed to put the main method inside of your classes. Since my main method is inside the class, it has privileges that a main method normally wouldn't have. Now, the trouble is in the visualizer, I can't have two files. Okay, I can't. So here's what I want to do. I'm going to take my main method. It doesn't belong inside of the rectangle. It should be a program outside of the rectangle. So I'm going to take main, and I'm going to create a new file. And I'm going to call this test rectangle. My main method will be in this class that tests rectangles. Okay, now I'll save this. So I'm testing rectangles. Okay, now here's rectangle. I'll compile it. Okay, now notice that when I compile it, now I get this error message. Okay, see, rectangle has this thing as private. So test rectangle is not allowed to put things in there. Unfortunately, this is one of the limitations of the visualizer. I can only have one file essentially. So that means I have to, well, actually I can fix this in the visualizer by doing one last thing. I'll put test rectangle down here. So I say, here's test rectangle. I think that a visualizer will let me do the following. Here's test rectangle. But what I do now is I change this one to I delete the word public from there. So now I've got two classes. This one is not public. This one is public. I need to pull the main method out of this. It's testing rectangle. It shouldn't be inside rectangle when it's testing it. Now, when I go here, see, width has private access in rectangle. See, now that fixes the bug. So the bug was because I had my test program inside of the thing I was testing, which is a subtle mistake. You know, in real Java, you should always separate the class you want to test and the code that tests it. They should be in separate classes. So I'm testing the class rectangle, so I need a class that tests rectangle. Now I can do that in the visualizer. So now notice here, both of these are public classes. But if I'm inside the visualizer, I make one of the classes non-public, and I make the other class public, the one that does the testing. And then in here, see, notice I've got the word private in here. Okay, private. See, there's public means that everyone can access it. Up here, these were by default public. I didn't write the word public there, but they actually are by default public. And what they need to be done is these should all be changed to private so that nobody can poke things in there. So that's what we'll pick up on Thursday. We'll pick up on this idea. This is one of the real cornerstone ideas in object-oriented programming, marking things as public and private. Like here, my class is public here. Right? I want to mark things as public and private, and then I want to make sure that nobody puts the wrong thing in my objects. Okay, so we run out of time, so we'll quit there. Anybody got any last second question? Anybody got a question? Okay, this is a really big idea here. Public versus private and protecting the data that's in the classes. The fancy word for it is called this encapsulation. Okay, we're gonna be talking about this idea of encapsulation. An object should encapsulate its data and protect its data. Okay, so that's where we'll pick up on Thursday. And if you got and also say remember there's a programming assignment out there. If you have questions about the programming assignment, we can go over them on Thursday. So if you have any questions about the current program assignment, if you want to ask on Thursday, that's fine. Okay, so I'm going to go ahead and quit at this point. Any last second question? Okay, so meet again on Thursday. Bye.